In this module, we're going to be looking at modulation techniques that are digital. So we're going to be looking at things that we use to transfer data back and forth for aviation purposes, also for other purposes, but we're going to be talking about a variety of things here. So the first one we want to talk about is the simplest one out there. ASK is amplitude shift keying. And what you have is a signal, it's a carrier wave, just like we've dealt with before, and the amplitude changes between low and high. So normally you'll have a logic 0 at one level and a logic 1 at another level, and you just move it back and forth between those things. Now, this is normally something that's used in pretty simple systems. One of the more interesting examples is some remote control for unmanned systems. It's also used for radio altimeters. You have it up and down, up and down, up and down, and it's bouncing off the ground. And what you do to get the distance from the ground is you notice the difference between when you send the rising signal and when the rising signal bounces back. So you get that delay. But amplitude shift keying is one of the easiest keying methods to implement for digital logic transfer. Now, the advantage of this thing, it's very simple to implement. From an electrical engineering point of view, it's extremely simple. It's low bandwidth, doesn't have a lot of problems associated with it. The disadvantages are it is susceptible to noise. So when you start dealing with noisy environments, things like that, if you've got things jittering up and down, that becomes a problem. At longer ranges, the signal decays and then it starts going down into the noise floor, which we've seen before. In the waterfall display, you can kind of see the noise. It fades down into there. And because it only has 2 levels associated with it, it does have limited data rates. So it kind of becomes a little bit of an issue there. It is more robust than amplitude shift keying. It's still a low data rate application because it's only got 2 levels associated with it. It does require more bandwidth. We saw that when we're doing the SDR++ type activities. If you look at an FM radio station, you can see on the waterfall display it's wider than it is for an AM station. So it is limited to lower data rates and it does take up more space in the band. Phase shift keying, you're actually changing the phase relationship, okay? And so if signals are going in phase or out of phase, then you can represent data with that. And the interesting thing is, because phase shift keying, there's multiple relationships there. You can have 2 signals that are in phase, that are 90 degrees out of phase, that are 180 degrees out of phase, 270 degrees out of phase. So those things become multiple signals, if you will, or symbols. So you can actually use it at a higher data rate than you can with amplitude shift keying or phase shift keying. PSK is actually used in GPS. So you'll see that in that environment for things that are going on. Its advantages, it's a higher data rate than either AFK or FSK. It's more robust against noise. The problems come, it's more difficult to implement. It requires more circuitry, it requires more decoding types of things. And at times you can get into phase relationship issues that make it a little bit hard to sort out some things. Now, it's efficient in terms of bandwidth, it's high data rate. It does have some susceptibility to noise, so you do have to worry about that at some point. But it is one of those things that you can deal with. Just kind of a table to show you what this looks like. This is a simple way to look at it. AFK, FSK, PSK, and QAM. The parameters that are modulated, ASK is just amplitude, FSK is phase, FSK is frequency, PSK is phase, QAM is amplitude and phase. And then as you go down the data rates, it starts off with amplitude modulation at low data rates and ends up with QAM with very high data rates. And then you can just see the rest of the table. So it makes it very easy to work with those types of things. Now, other applications that you see out here, these techniques are used in a variety of fashions. Part of it's ASK is common in RFID, so little barcode types of things, not barcodes, little radio frequency things that you see, radio frequency tags. FSK, broadcasting and telemetry. PSK, satellite, Wi-Fi, Bluetooth. So you're actually using this stuff all the time. You just don't necessarily realize it. Every time you put your earbuds in, you're using PSK. QAM, it's digital television, broadband internet, all of those things that we depend on every day.